Hi, this is Alex from devstories.eu. LangGraph, Episode 2 of 18. You build an artificial intelligence agent by stuffing instructions, edge cases, and examples into one massive prompt. Then you send it off and hope it does the right thing. It works until it fails, and debugging the result is frustrating. To fix this, you have to stop writing monolith prompts and start designing systems. That brings us to thinking in LangGraph, the mental model. LangGraph forces you to step away from linear scripts. It asks you to think about your application as a state machine. The very first step is to simply define your process. Before writing any code, look at what you want the system to achieve and break it down into discrete actions. Consider a customer support triage system. A user sends a message. A human operator would read the email, decide if it is a billing issue or technical support, and then draft an appropriate reply. That sequence is your process. You map that process to a LangGraph workflow using three core components, which are state, nodes, and edges. Let us start with state. State is the shared memory of your graph. It is a structure that holds the context of your entire operation at any given moment. Every step in your workflow will read from this state and write updates back to it. Listeners often make a specific mistake here. They try to store fully formatted prompt strings inside the state. Do not do this. The state should only hold raw data. It holds the original customer email text, the extracted category, or a raw list of previous messages. Formatting happens on demand, later, exactly inside the step where it is needed. Next, we have nodes. If state is the memory, nodes are the workers doing the actual tasks. A node is just a Python function that executes a single logical step of your process. It receives the current state, performs an action, and returns an update. In our triage example, you would create three separate nodes. The first is a read node. It takes the incoming email and saves the raw text to the state. The second is a classify node. It looks at the raw text in the state, asks a language model to categorize it as billing or technical, and saves that resulting category back to the state. The third is a draft node. It reads both the email and the category from the state, formats them into a prompt locally, and generates a response. Each node does exactly one job. Finally, you need a way to connect these workers. That is the role of edges. Edges represent the routing logic. They dictate what happens after a node finishes its work. A standard edge simply says, once the read node finishes, always go to the classify node. But LangGraph also uses conditional edges. This is where it gets interesting. After the classify node, you can use a conditional edge to inspect the state. If the category is billing, the edge routes the flow to a specific billing draft node. If it is technical, it routes to a technical draft node. Edges make traffic decisions based on the data your nodes just produced. You start with the process, you isolate the data into a shared state, you define the workers as nodes, and you dictate the flow with edges. By breaking the problem apart, you isolate failures. Treat your application not as a single text generator, but as a coordinated assembly line where raw data moves systematically from one specialized worker to the next. Thanks for listening. Happy coding, everyone.